Performance is low. Flow is not enough. Pressure looks weak. And the first reaction is almost always the same. Let's install a bitter motor. More power should solve the problem. At least, that's what most people believe. But here's the unfiltered truth. Motors don't fix system limits. A motor only supplies power. The system decides what actually happens to that power. Every real system has limits. Valves restrict flow. Pipes create losses. Heat transfer caps output. If the system is already at its limit, adding more motor power doesn't improve performance. Instead, something else happens. More power turns into more losses. That extra power has nowhere useful to go. So it shows up as heat. Bearings run hotter. Seals see higher stress. Vibration levels increase. Noise goes up. The system doesn't perform better. It just wears out faster. This is a very common real-world scenario. The motor is upgraded. The piping stays the same. The valves stay the same. The bottleneck stays the same. And the output barely changes. Flow is almost identical. Pressure is almost identical. But failures start happening sooner. Why? Because higher power means higher stress. Shafts see more torque. Couplings see more misalignment forces. Bearings see higher loads. Seals fail earlier. Reliability goes down, even though performance didn't go up. Now, this doesn't mean more power is always bad. More power helps only when the system allows it. If you remove restrictions, if you reduce losses, if you redesign the flow path, if heat transfer capacity is increased, only then can additional motor power be converted into useful work. So here's the correct order of thinking. Fix the system first. Identify the bottleneck. Reduce losses. Improve flow paths. And only then, size the motor to match the new requirement. A bigger motor can destroy your system when the system is the real limit. Subscribe to Engineering Unfiltered for real engineering, no filters.